Today, I want to finish up on 6.4. This is the physics section of notes that we started last time that we didn't finish. So I think we had just finished this problem, and by the time you guys had walked out, I realized I made a small mistake here. So take a moment, reread through the problem, look at the setup that we've done, and see if you can pick out the mistake. It's subtle, but it's going to give us the wrong answer.
It's stretching. I know, I just want to give other people.
Appreciate that.
Sure. Thank you.
What did you say?
I know that. I just want to give other people a chance.
Isn't it Alice?
Mr. Last one.
Alice is on it. Yeah, it's the bounds are the problem.
Oh, it shouldn't be.
We're going to watch a movie today.
Is it not 18?
Oh,
so you know it's only the bounds of the problem.
3 inches, so
It's point three.
No.
You know what I mean.
It's 10 to 18.
I mean, you're on the right track.
So, oh boy, that was weird. Why that?
Because the units.
Its natural length is 10, right?
yeah.
So it's only been, you're starting at 5 centimeters stretched and going to 8 centimeters stretched, right? 10 is like 0 for us. Okay, does that?
Yeah, that makes sense.
Okay. All right. I think I got 2 more examples to get through here. Then I'm going to give you guys a take-home thing to work on, and then for today. It says a 200-pound cable is 100 feet long and hangs vertically from the top of a tall building. How much work is required to lift the cable to the top of the building? What's gonna make this maybe not obvious?
Weight.
Yeah, what's the matter with the weight?
Weight is mass times something.
It's already like
Put on your physics hat.
it's in pounds.
Weight is not a concept.
Now the pounds isn't the issue.
Oh, it's not. It's already like a force, right?
A pound, yes, weight is already a force.
It adds to the force because it's already hanging from the top of the tall building.
So let's picture it this way, right? We have like 200 pounds 200 pounds of cable hanging off the building, right? If I pull 1 foot in, how much weight is now hanging off the building?
99.
Well,
Still the exact same.
I meant
no,
200 pounds.
because there's like a foot sitting on the ground next to me.
198.
198 pounds, right? And if I pull in another foot, how much weight is hanging off the building? So what's going to be variable?
To the amount of weight.
The amount of weight that I have to pull in, right? Everybody sees that? The further I pull that rope in, the lighter this cable's getting, because there's less of it hanging down. There's some more of it piled up by my feet. And that should make sense, right? If you've helped a friend up, which is harder, when they just lay turtled on their back or when they put a hand or a foot down?
Foot down.
The hand and the foot down. Why is that easier to lift them up? Because they're like taking off some of the weight, right? Does that make sense?
Yeah.
So, how much does this cable weigh per foot?
2 pounds per foot.
Yeah. Right, so that's what we're moving. Everybody agree? Okay, so our force is going to be dependent on how much cable we're pulling in. Everybody agree? So when we pulled in like 0, this should be like 200 pounds, right? If I pulled in 50 feet of cable, it should be down to 100 pounds, right? So my work is going to be the integral from 0 to 10.
That's 100.
I'm sorry, 0 to 100 of 2x dx. right? Because I'm moving 2x is my force, right? And my dx is my distance. Everybody okay there? And that's the setup for that one. Now, again, putting on your physics brain really mattered there, and thinking about, like, actually me physically pulling in this cable, like, is it going to get easier as I pull it in? It should, right? Because the cable weighs, the amount hanging weighs less and less the more I pull this in. Does that make sense?
Yeah.
And then from here, the calculation is easy. I'm not going to bother with it, but that's the setup. All right, the last one's a doozy. Oops. A tank has the shape of an inverted circular cone. Don't you love it when it starts like this?
What?
With a height of 10 meters and a base of 4 meters. Or a radius of 4 meters, filled with water to a height of 8 meters. Find the work required to empty the tank by pumping all the water to the top of the tank. Note that the density of water is 1,000 kilograms per meter cubed. So here's our inverted cone. Everybody okay with the picture we're drawing? Okay, so that cone is filled up to 8 meters to start. Everybody's okay there? So, what is the force that's going to be going on here? That I'm going to need, that's going to generate the work, right? Work is force times distance. So what is my force going to be?
80.
So the force is going to come from the mass of the water that I have to move against gravity, right? So gravity is generating our force. Everybody's okay with that? So far, so good? Okay. So gravity, we know that, right? What is gravity? Physics kids? Yeah. And everything is in meters, so we don't have to do any unit. Okay? Not 10. We're in math class. We don't make that approximation. We're not afraid of decimals. Now, the mass of the water that's being moved is going to change depending on how much water is left in the tank, right? So what we're going to be thinking about is like moving just like a little tiny cylinder of water. Right? So that mass of that is going to be the is going to be like the is going to come from the volume of the cylinder here, right? So we know that like density is equal to mass over volume, right? Everybody remember that from chemistry or physics? No? It's the amount of stuff you have in a given space, right? That's what density means,
Yeah.
right? So we can say then mass is density times volume. So we have our density is 1,000, and our volume is going to be pi rw squared, times, like delta x. Is everybody okay with that? Or really, we're going to think about this. This will be like become like our dx later.
Because volume is, yeah.
Volume of a cylinder is pi r squared times height, right? Everybody feel okay so far? And we're going to be moving that then some distance of x. Everybody agree with that? So my work calculation is going to be some integral of force times distance. So my force is going to come from this, and then I'll have like a times x on it. What do you notice that's the problem with this integral that we've written? I have, well, there's no bound, sure, but look at the expression inside that we're going to be integrating. How many variables are in there?
3.
Well, 2 really. I have RW and X. Can I integrate something in terms of 2 different variables? Guess what I'm going to need to do? You have to eliminate a variable. Which one do you suppose is the one that I'm going to eliminate?
RW.
RW is correct. So the idea here, what I'm going to look at, is I have this triangle. And then I have that triangle. I'm going to build a similar triangles argument, much as what we did when we did related rates when we ran into these cone problems. Same similar triangles argument. So I'm going to say that RW over this side is equal to 4 over 10. Everybody's okay there? We see where the 4 and the 10 are coming from?
Yeah.
Okay. What is this side in terms of x?
Oh, 8 minus x.
Close. 10 minus x, yes. So the top of the cylinder, but good. Do you see why? You said this distance was x, and this whole thing is 10, so this spot has to be 10 minus x.
Yeah.
Okay. So if we do a little rearranging, we have that RW is equal to 2/5 times 10 minus x. All right there.
I trust you.
I think that's right.
That's cool.
Yes.
Okay, so off topic question real quick.
Can we wait till we finish this?
Yeah.
If it's off topic,
Yes,
I'd be happy to deal with it, but let's get through this in one train of thought.
I agree.
As best as we can, anyways. Is that okay with the setup and what we've done, right? So it's just been force times distance. Now, it took a little work to get to our force. Everybody's okay?
Could use any variables of that, right? Like the
Yeah, me calling it X, you could have called it like H or, like I picked a different, I just picked X because I like to use that as my primary variable when it's, and I don't think there's any, you could call this Y because it's a vertical distance or whatever, like whatever,
like that when I make it.
Not enough. Brooks.
So you said force was mass times 9.8, and then the 9.8 and the mass just like disappeared to 1,000.
Oh, yeah, that should be, let's make that 9,800 then, right?
Oh,
We'll do that.
so then that should be it.
Yeah. did. It was important. Oopsie on my part. Now we just need the bounds. Right? So x is representing the distance that we have to pump the water. What's the shortest distance we have to pump the water? Would be right here at the start, right? How far is that? 2. And what's the furthest distance we'd have to pump the water when it's all the way down at the bottom? 10. Right? Because we have to pump it from the very bottom of the cone all the way out the top. And I think that'll do it. Does that feel okay there? So again, choosing x is like the distance that we have to pump. You know, this is the first time we've used distance as not dx. Because we had to use dx for the slice of our cylinder there, or slice of the water that we're pumping out. Does that feel okay? The takeaway here, though, the thing that I really want you guys to take away from this, one, we did these physics problems for the future engineering students that are like, I'm going to have a lot of physics classes in front of me, and like doing some calculus-based physics is nice to have seen a little bit of. Two, though, the idea that all we're doing here is if I'm accumulating something that has a it's variable over time, the way to do that is with an integral, right? If I integrate the rate over some time, I get the accumulation of that stuff, right? If I integrate velocity, like miles per hour over time, I collect miles, right? If I integrate like fish per hour swimming across the dam, and I integrate that over time, I'm going to get fish, right? If I integrate, like work done over time, I'm going to accumulate like joules, right? Like work. I accumulate the work. Does that feel okay? And that's the piece that like will appear on APs. Like they'll give you rate variables and ask, like in some of these FRQ style questions, like how much, like things are coming in at this rate, leaving at this rate, like how much stuff accumulates over this time. And that's one where it's like, oh, okay, all I need to do is integrate in minus out rates, and that'll give me the stuff that accumulated over that time. So that's the piece that I really want you to take away from this. This is yet again another example of we use integrals to just as an accumulation function, right? Like we're accumulating area under the curve was kind of like where we started with this. Now we've branched off and we're looking at accumulating real world things. Brooks.
Is that because when you take a rate, or when you take a derivative, you figure out the rate, but because a derivative is the opposite of an integral, when you take an integral, you're getting rid of the rate to figure out?
Yeah. Yes. Right on. Does everybody feel okay with that idea, that concept? We'll do some specific AP style accumulation practice next class. Okay? So I have some FRQ stuff that I'll hand you and we'll just kind of work on next class. What I have for you to do for me for next class is I have this chapter 6 questions. These are either volumes or just basic integrals of rational functions. Those are the two, I think, deepest topics we spent time on here, are the two that I need you to take away or walk away with from this unit the most. These are take-home test questions. You're going to do these, bring them back next class. I think I have it set up 5, 10, 15, 25, 30, 35 points total on this thing. So they're like 5 points a pop. The volume questions, the directions are all set up but do not solve. Right? So you don't have to go beyond the setup. So the things I'd be looking for grading wise are going to be like, did you pick a correct method? Did you formulate, like your radius or your side lengths or whatever in there in terms of the correct, in terms of the correct variable correctly? Are you integrating with the correct variable? Are your bounds set correctly? And I'm just going to kind of check through on those things, like a point per thing. The front page are some basic, or some of these rational function integrals. Remember, there were the methods we had to do those were like use a tan inverse, or do polynomial division, or partial fraction decomposition, depending on kind of the form of your integral. Is everybody cool with this plan? I'll give this to you now. You can start working now if you'd like. Everybody feel okay on that? So this is like some take-home test points. I know that some of us feel like Mr. Kulik kind of got me feeling one way and then pulled the rug out from under me when we realized that we had done the grade book wrong, and this is me trying to like throw you guys a bone here and give you some points that are, like easier to connect in a way, I guess.
How much was time variable?
Yeah, like 20 minutes or something.
Question 4 is like.
We end at 55.
Cool. Maze rush.
So are we reviewing next class?
This is the way the
Yeah, so test 6 is going to be coming next week. So let's see here.
Wait, Mr.
Yeah. Let's talk for a minute. So I don't know is the answer right now, but let's talk it out, right? Like I don't have any problem with letting you guys in as part of the decision. So this is the test format. So part 1 is no calculator, 3 rational expression integrals, very similar to the take-home problems that you're looking at right now. If you feel good doing the take-homes, you should feel good on that part. 2, find the area between 2 curves, set up only. 4, find the volume, set up only. Okay, so just like this take-home thing is basically like a pared down version of that part 1, right? Part 2 is 6 multiple choices and 1 FRQ that's an accumulation style AP pre-response FRQ question. We'll do some practice on those next class. That's the format. Notice that average value didn't pop up on any of the specific questions. Where's that going to probably land? In the multiple choice section, right? The things that don't appear like blatantly as like, oh, we definitely did that, spent some time doing that, like how come that's not listed anywhere? Probably it's going to live inside of the MCQ land. I do have test 6 MCQ practices that I picked out for you guys from the AP site on here. Yeah, that's the test format. Does that feel pretty clear as to like the stuff to look over? I think doing this sheet that I gave you beforehand will be quite helpful in terms of like forcing you to prepare for the stuff you need to be able to do. Because I think it's a pretty fair representation of like the level of difficulty that you'll run into. Now on your question, you have like the same area or the same like shape every time. Like on the test, the shape will vary a little bit between the questions. Here you're just gonna get the same. For paper purposes, let me fit this all into one sheet. I just did one shape for you guys or one area. So in terms of a test date, we would meet again Monday of next week would be the first day this class meets. Is that an acceptable test date? Is that too close to something else? I think that's a standard length class period. I think we have a stations across coming at some point here next week or the week after, before spring break anyway.
Yeah, it's the Monday before spring break.
Yeah, so I'd like to kind of get this thing in and get on to the next stuff. We spent enough time with this material to where we're starting to feel more comfortable with it. I've stalled here a little longer than I normally would on some of these topics because I felt like you guys needed it. And that's fine. We have the time to spare to do that. Lucas, did you have let's see, you had a hand up or no?
Well, no, I just wanted it to be.
You just want it to be on Monday?
Monday. I was gonna say, we have Kairos next week.
Well, no, because we don't have last Friday.
Yeah.
So so Monday is a B day? Okay. So Tuesday then, I'm sorry, will be the test day. Sorry, thank you for sorting that out for me.
Yeah, maybe they live after school. Well,
Yeah, we're gonna
not
check it
here.
out.
Oh, no, you'll be fine.
Yeah, we'll be good.
It's after school Tuesday.
Is that acceptable?
Yeah, that's good.
Are a bunch of people going on another Kairos here? Is that we're trying to arrange this around? Yes, I'm happy then to cram it in before you go on that. The people that had to take it late last time, I feel like, did not benefit from that at all. So, yes.
Can I wash my hands?
Of course.
Here.
Yeah, no problem.
No.
Okay, so let's set that as our date then. Everybody feel good on that? Okay. I'll get that in the calendar here sometime this week. Fingers crossed. That work for you guys? So next class we'll do some of this accumulation FRQ practice. If you guys have other things that you've come across that you're like, hey, can we do a little bit of this or that or the other, we can squeeze some time in for that. It's only 40 minutes or something, or 50 minutes next class, so basically that half-day schedule because of the games in the afternoon. Yes, Pat.
Are they doing it like in between second and third hour?
What the games?
Yeah.
No, we do the whole day.
All the class games.
Today, the concert and games are after second period.
No, not 2 hour gap.
Pat, the schedule is taped to the board up there if you want to take a look at it for the next couple of days. Okay, everybody happy? Alright. Any other questions for me?
Are we going to CT after this?
I don't know. I assume that they're gonna get on the PA and tell us how we're gonna dismiss from here, but I don't know why we bother going to CT. I think that's a big fat waste of time. To like go to this other room and now put your stuff there and now go to a different room, you know, it's like why not just leave it? I don't know. But I don't know.
Great question.
We do it at Mass all the time.
We do.
Today's the trivia.
Concert and trivia today.
How long is that gonna be?
I don't know. The schedule is on the board over there though. Take to it.
Concert is from 10 to 10:50, and then church is 10:50.
Wait, is it a concert or is it
2
a
hours.
singing thing?
I think
I was like that.
I think that both
Because I was like the karaoke thing.
I think both choir and the band are
It's like the high hopes festival.
that is that ends the concert, yes.
Got it. I remember that now.
How much are
Like shots.